Okay, so here's an application problem, and I think that we're going to find that when we do these, that there's oftentimes more than one way to maybe approach it and look at how to do it. But I'm going to show you a specific way, and there is a rationale to it. All right, so let's check this out. So we have this cube of clay. It says Potter has a cube of clay with an edge length of x inches. All right, so that means right? So that to me makes me think, okay, I'm going to be doing something with volume with the clay. And so basically you just need to remember that the volume of a prism, all right, and if you don't remember this, this is a very basic one. You have to remember this one. The volume of a prism is just basically, you know, the length times the side times the, you know, the depth or whatever, however you want to put it, right? And so length, width, and height, I think, is the length times width times height. I think that's how they do it, right? So this would be your height, right? This would be your width. This would be your length. Or you could do it. It really doesn't matter what order you put it. But it's going to give you something that's in units that are cubed, all right? And so that's kind of the little review here that we have to think about. And now she cuts a smaller cube with an edge length of 3 inches out of the corner of the big cube is shown. All right, so that means that the volume of this smaller cube, right, is this times this times this, right? So it's 3 times 3 times 3, which, if you didn't know, is 3 cubed, right? And that is, that's 27. Okay, and then it says if the volume of the remaining clay, so that means this stuff that's blue, is 316 inches cubed, what is the edge length of the original cube? All right, so they want us to find x, basically. That's what they're saying. They're saying find x. Great. So this is the information I know. I know that the volume of this prism, right, is going to be x cubed because it's length times width times height. They're all x, so it's x times x times x, right? And if you have that, we would write that like this, right, as x cubed, right? So that's my volume of the prism. And then the volume of the smaller cube is this. And I know that the volume of the remaining clay, so in other words, if I take the volume of the overall prism, right, and I subtract the smaller cube from it, it's going to give me this remaining volume right here, 316, okay? So, so we have a problem here that we can work on now, right? We've got an equation. So what we're going to do is we're going to get everything over to one side so that we can use our zero property, factor and use our zero property. Now there is another way to do this, all right? And that way is to move this over and then just take the cube root of everything. However, when you do that, a lot of times it neglects the fact that there are complex solutions. And we wanted to show you that there are complex solutions. So we're going to do it this other way. Okay, so it's a little longer, but it's kind of important that we understand it. So we're going to subtract 316 from both sides. All right, and you get 0 over here. You get x cubed minus 343. Okay, you can use a calculator for that. Remember, when they're both negative, just add them, right? So 7 and 6 is 3. Carry your 1. 1 plus 2 is 3. 3 plus 1 is 4, and then you get 3. Now, hopefully you recognize that this is a difference of cubes, all right? Because 343, all right, 343 happens to be 7 cubed, all right? And this is why you kind of need to know some of your cube numbers now, right? So, so you can recognize these special cases when we get them. All right, so what we're going to do now is we are going to factor this. All right, so we are going to factor x cubed minus 343. So let's do that. So if it's a difference of cubes, that means we're going to take the cube root of x cubed. So we got x cubed, and we're going to cube root that, and that's going to give us x. We're going to take the cube root of 343, and that's going to give us 7. And I know that because we already figured out it was 7. So you start with, you're subtracting 1, your x minus 7, because that's how the difference starts, right? Remember, the difference is a minus b, and then a squared plus ab plus b squared, all right? This is your formula for difference of cubes, right? Diff of cubes formula. All right. So now let's write this part, this a squared. Well, a is basically this, and this is b. So a is x squared plus my ab is 7 times x, which is 7x, and then b squared is 49. That's positive, right? And so this is our factored form, and this is equal to 0. So we have two things we have to set equal to 0. So we got this one and we got this one, all right? And so we're gonna do this one first, all right? So you get x minus 7 is equal to 0, and then you get x is equal to 7, and this would be inches, right? Because it's cubic inches. So this is one solution. Now you may be thinking, well, how can this thing have more than one solution? Well, it really doesn't. It does have just one solution. However, we need to show you that there are cases where there's complex solutions too when you're doing something that's not an application problem. And so we're gonna show you that. So we've got this other thing. We've got this x squared plus 7x plus 49 that we have to equal to 0. Well, as you know, because we've talked about this, we know that this is prime. All right. Otherwise, they would have taught you another factored form of this, but this is prime. So if it's prime, that means the only way that you can solve this is through either completing the square or using the quadratic formula. And personally, I think most of you did better with the quadratic formula. So that's how we're going to do this. So we're going to say x is equal to negative b plus and minus square root of b squared minus 4ac. Yes, I do have this memorized because if you use it enough, you memorize it, right? So this is equal to negative, now my b is 7, plus and minus, and then my b squared is going to be 7 squared minus 4 times 1, because that's my a. My c is 49. Hopefully you can see your discriminant's going to be negative, so that's where you're going to get a complex number. And then 2 times 1, because that's 1. All right, so let's keep rolling with this here. All right, so this is going to give me negative 7 plus and minus the square root of 49 minus whatever 4 times 49 is, which is, well, 4 times 50 is 200. So 4 times 49 would be 196 all over 2. So that means that we will have equals to negative 7 plus and minus the square root of, you take 49 away from 196, and it's going to be a negative number. So 6 minus 9 is 5. All right, you turn this into 8, and you get 4, and you get 145. That's what I get. I don't like that, but oh, you know what? 6 minus 9 is 7. Right, 16 minus 9. Right, it's 7. I don't know what I'm doing here, right? But yeah, so you have 147. Okay. So that means we have negative 147 in here because this is your negative number and it's larger than the positive. Okay, and this is all over 2. All right, so your complex solution is going to be this. You're going to have two cases. You're going to have negative 7 plus, and we're going to pull that I out from the negative, square root of 147. 147, you can't really do much with this, right? It's not, you can't pull any square numbers out of it, right? So we're gonna do this, and then over 2, and then your other case is negative 7 minus I times the square root of 147 over 2. Okay, and so these are your other two solutions, right? Now, in this case, these, do not apply, right? Because we're talking about a real world problem. But when they're asking you to find solutions of something with something like that, that is where you're going to go. So that is how this works, and I hope this helped.